All right, let us solve this rational inequality. As soon as I see that less than sign, I know that this is one of those problems that's going to have a number line, and I'm going to plot some critical points and do some test values and such. Okay, so we'll see how it goes. Now, the question though is, how do I find out what numbers go on this number line, what the critical values are? The critical values actually have two sources. One thing that goes on the number line will be any excluded values. So for example, at a glance here, I see that x cannot equal 5. All right, I'm setting this equal to 0. That is going to go on the number line. That's a critical value. The other critical value I can find from solving the related equation, 3x minus 5 over x minus 5 equals 4. All right, if I set up this equation and solve it, we need like denominators to solve this. So I'm just going to give this an x minus 5. Got to put it in the numerator as well. Once we have like denominators, we can go ahead and cancel those out. So we have 3x minus 5 is equal to 4x minus 20. I will subtract 4x from both sides. So that's going to leave me with negative x minus 5 is equal to negative 20. I'm going to add 5 to both sides. So that's going to give me negative x is equal to negative 15. Dividing by negative 1 gives me x equals positive 15. All right, so that is going to go on my number line as well, x equals 15. All right, so that's it. I'm going to put these two critical values on my number line. Now remember, excluded values are always graphed as open circles. All right, because an open circle shows that this value will not be included. It is excluded. On the other hand, the solutions to the equation that we just solved, these will sometimes be open and sometimes be closed. If we have a less than or equal to, then it's going to be a closed circle. But if it's just less than, then that's going to be an open circle. Okay, so in this case, we just want to know where the function is less than 4, not equal to 4. So this 15 is where the function is equal to 4, so we don't want to include that. So this will also be an open circle. Okay, so I've got my I guess I should put the values down. So this is 5 and this is 15. So now we do our test values. So over here I'm going to do 4. And in between here, between 5 and 15, I'm just going to use, let's say I'll just do 10. And over here, I will do 16. All right, so I'm going to check those values. Now, here's one thing. Do I even want to say this? So just be careful. Right here, normally we have a 0 over here. This time we don't. This time we have 4, less than 4. So when we do this, we're going to see whether or not the function is less than 4. Not 0. Okay, so here we go. So I've got 3x minus 5 over x minus 5. Ask x. All right, and I want the values 4, 10, and 16. So 4, 10, and 16. All right, so I've got -7, 5, and what was that? 43/11. Okay, and remember the question is, is the function less than 4 at these values? So is 7 less than 4? Is 5 less than 4? Is this fraction less than 4? So is -7 less than 4? Yes. Is 5 less than 4? No. What about this? Well, you know, it would be helpful to look at the decimal version. So highlight it, toggle it, 3.9. Okay, so considering that this is 3.9, is that less than 4? Yes. Yes, it is. All right, so we have a yes, no, yes. So that means the solutions are in this area and this area. So there's a graph of my solution set. So in interval notation, that would be -infinity to 5, all right? It's going to be round because open circle. And then 15 to infinity. Again, because it's an open circle, I do round parentheses. All right, 15 to infinity. So this would be our interval notation. Okay, let's go ahead and do one more problem on this video. Number 6. Okay, this one's going to have a little twist at the end. Got to watch out for it. All right, so again, we're going to draw a number line and graph those critical values. And the critical values come from 2 places. Some of the critical values will be the excluded values. So because of this, x cannot equal 0. Because of the x plus 3, x cannot equal -3. So those excluded values will go on the number line. They are critical values. The other critical values we will get by solving the related equation 1 over x equals 1 over x plus 3. Whatever the solution or solutions to this will be critical values that go on the number line. So let's solve this. So this has an x and this has x plus 3. Whatever you do, do not think that you can add 3 like this. And like, oh look, now I have x plus 3 and x plus 3. No, 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 no. Adding something to the numerator and denominator does not give you the same value. You can only multiply. So what I'm going to have to do is multiply by x plus 3 in the top and the bottom. Okay, now that makes these almost the same because they both have x plus 3. But this also has x. So I'm going to multiply by x in the top and the bottom. Now the denominators are the same. So I can go ahead and cancel these out and make a new equation using the numerator. So x plus 3 is equal to x. Okay, this is going to be weird because when I subtract x from both sides, all the x's cancel out. So I get 3 is equal to 0. Okay, so that is not valid. So that means this equation right here has no solution. So as soon as I put that equal sign in here, that's no solution. That doesn't mean the answer to the entire problem is no solution. That just means we have these 2 critical values, and I was going to solve this and get another critical value or 2, but this means there are no additional critical values. But I still have the 2 from the excluded values, and so I'm just going to use those. So we're done with this blue stuff over here. So we are going to go ahead and continue the problem using these critical values. So we have 0, and we have, whoops, it's the wrong order. So put in order, we have -3, and then we have 0. Because these are excluded values, we automatically make them open circles. All right, even though the equation is less than or equal to, excluded values are always open circles because they're excluded. You can't include them by making them closed circles. So now we need test values. So over here to the left of -3, I'm going to do -4. Between -3 and 0, I'm going to do -1. And to the right of 0, I'm going to do +1. Okay, now here's where the tricky part comes in. I want to evaluate these and see if it's less than or equal to, but because this is not a single number, it's going to be really hard to tell. You know, it's like I would have to evaluate both sides and then compare them to each other, and I'm trying to use my calculator to do it. It would be really tough. So here's my suggestion. Let's change this equation to another form. Imagine that you had, for example, x is equal to, or say if you had x squared plus x is equal to 5. If you wanted to get 0 on one side, you could subtract 5 from both sides. You could basically move this over to the left and it would become negative. So you would have x squared plus x minus 5 is equal to 0, right? You could just basically move this over and make it negative. So that's what I'm suggesting that we do with this whole problem. What if we take this entire half of the equation and let's get 0 over here. But let's take this and move it over to the left. All right, let's subtract this entire fraction. So the equation would become 1 over x minus 1 over x plus 3 is less than or equal to 0. Okay, I just subtracted this from both sides. I moved it to the other side and then it became negative. All right, now I just have a 0, so it'll be very easy to compare. Now I can put this in my calculator and compare it to 0. So that's the trick. So in my calculator, in the table feature, I'm going to go 1 over x minus, so 1 over x, whoops, minus, then 1 over x plus 3. All right, make sure you're in Ask X mode. All right, now the three values at which I want to evaluate are -4, -1, and 1. So -4, -1, and +1. Okay, so 3/4, -3 over 2, and 3/4. What was it? -3 over 2. And because we rewrote the equation in this form, we're now asking ourselves whether or not the function is less than or equal to 0. Okay, so that's the trick. So anytime you have, if you don't just have a number here, if you have a variable expression on both sides, just get 0 on one side and put that in your calculator and compare to 0. So is this less than 0? No, it's positive. Is this less than 0? Yes, it's negative. Is this less than 0? No, it's positive. So my yeses are here. My solutions are between -3 and 0. So this is a graph of my solution set. And in interval notation, that would be -3 to 0. And I will have to use round parentheses because of the open circles. And that's how it's done.